डॉक्टर बाबासाहेब आंबेडकर ओपन यूनिवर्सिटी.
Hello friends, welcome to the Babasaheb Ambedkar Open University. Myself Pooja Gandhi. Today we are starting the subject Digital Electronic and Computer Organization. The subject code is 203. Subject contain mainly the 3 units and each unit contain the 2 blocks. Fine. Now before we starting this block number 1, first I am going to explain you what is the importance of the subject into the computer science field. Why this subject is introduced into the computer science field. See what happened when we have to memorize something or we have to explain something, we can memorize it easily or we can explain it easily. Why? Because human have the brains, but in the case of the computer or in the case of the machines, machine does not have the brains. Fine. So how that machine will interpret the information, how that machine will store that data. Fine. That all about this subject. I am giving you one example. Suppose we went one restaurant, we took the dinner over there. Fine. And in the last, suppose the manager asked for the review or rating. Now we having the 2 options. That one option is manager offer us 2 forms. Fine. In the one form which contain the rating from 1, 2, 3, 4, 5, and in the second form that manager has given us which has only 2 options. That means the restaurant is good or the restaurant is not good. 80% of the people will choose the second form for the review. Why? Because it is easy. It is easy to remember. Only the state, means we have only the 2 state, that restaurant is good or restaurant is not good. Means rather than for going for the first option, majority of the people will go for the second option. Computer also will follow the same thing. Fine. Rather than to store the different number, to store the different alphabet, to store the different character, it will also go for the different state. That means it will interpret the information, it will interpret the data into the different state, majority of the time into the 2 state. For example, like true or false, like yes or no, like slow and fast, like high and low, etc. Fine. We will see this in detail in this chapter. Okay. Now see, first we start today the first unit, that is the first block, that is the number system and Boolean algebra. Fine. Now see, this is the first unit that is the number system. Again, before starting the number system, this unit, we will see what is the importance of the number system or why we study this number system into the computer science field. Okay. See, we heard from the very early age that maths is the very important subject. Fine. But today we will actually implement the number system and we will actually implement the maths, that is only for the computers. Fine. Now see, from very early age there were no such mathematics, means there were no such advanced mathematics, but at that time also the people were very strong in the mathematics. Then how they will count the number? Fine. At that time no number system was introduced, even though those people were very strong in the counting. Then what the people were doing at that time? See, basically in the number system there are mainly 2 types of the number system. First one, that is the non-positional, and second one, that is the positional number system. Now see, what is the difference between non-positional and positional number system? Non-positional number system, that number system were used by the people in very early age. What is the difference between this? Non-positional number system means there is no importance of the position for that number. For example, you can use different digits for that number, but there is no importance of the position for that number. For example, how the old people will save the number, how they remember the number. So first, suppose they are used to write suppose 3. Fine. What is the first of all meaning of the non-positional number? Suppose we write the 3. 3 is just an symbol. There is no importance of the position. We can write 3 in this way. We also can write 3 in this way. We also can write 3 in this way. Fine. There is no importance of the position. Again, suppose we are having the number 2. We can write in this way. We also can write in this way. We also can write in this way. Fine. Now, what the early people was doing in counting the object at that time? So, first of all, suppose we are having the 3 apples. What the people were doing at that time? They can count like object like this 1, 2 and 3. That means this means these are 3 apples irrespective of the position. Fine. So, these number are also called the unary numbers. Now, see what is the problem in the unary numbers? The unary counting and the unary numbers are very limited. Fine. We cannot count the 100 apples by using the unary number. Otherwise, that task will become clumsy. That task will become very complex, and that's why they introduce the next number, that is the decimal number. Now, see, that's why they introduce the next number, that is the decimal number. Now, see, all the numbers are not used by the computer. Mainly positional numbers are used by the computer. Decimal number is the part of the positional number. It is the one type of the positional number. Now, why we first introduce the number system? It is just represent the quantity of the object, and that's why they introduce the number system. These are the examples of the non-positional number. Fine. Next is the introduction of the positional number. Now, see what is the meaning of the positional number? Positional number means the number has some specific position, and second thing, that position has some meaning. For example, suppose I am writing 2 over here, then this 2 has the meaning only 2. Fine. Suppose we write 23, now this 2 has the meaning 20. Suppose we write 213, then this 2 has the meaning 200. This is the importance of the positional number. Fine. Now, see why this 2 has the meaning 2, why this 2 has the meaning 20, and why this 2 has the meaning 200? Because this 2 is at the ones place, this 2 is at the tens place, and these 2 as the 100 place. If there is the next number, then that will be at the 1000 place, next will be at the 10,000 place, and so on. So, how the first of all the number are formed? Suppose we are writing 23, what will happen? 3 has the unit position. Fine. 2 has the tens position, that's why we multiply 2 into 10 raised to 1 and 3 into 10 raised to 0. It will make the number 23. Remember one thing, any number raised to 0, that will give you always 1. Any number raised to 0, that always gives us the number 1. Fine. This is how the generation of the decimal number, or how the generation of the positional number. See, now there is no only one positional number, that is the decimal number. There are other positional number. These are the common positional number. First one is the decimal, that we already seen. Second one is the binary. Third one is the octal. Next one is the hexadecimal. Now, see, from among this number, binary number, octal number and hexadecimal number, they are used by the computer in direct or indirect way. Fine. Binary number are used by the computer, that are not used by the humans. Why those are not used by the human? Because human cannot manage the combination of the 1010 at all the time. Fine. Secondly, binary number are directly used by the computer. Next, octal number are not used by the human, but they are in indirect manner used by the computers, and hexadecimal numbers also not used by the human, but they are used by the computers in indirectly manners. Now see, first we will see what is the base for the number. Why, if we have the decimal number, then why we have need of these three numbers? Why we introduce the binary numbers? Why that introduce the octal number, and why we introduce the hexadecimal number? Now see, what is the problem in the decimal number? Why there is the need of the binary number? Actually, there is the no problem in the decimal number if decimal number are used for only the humans. Means if the human are fine with the decimal number, there is no issue in the decimal number. But if we are talking about the computers or machines or electronic devices, I am again repeating, computer devices, electronic devices and machine that cannot memorize this much of the symbols. Fine, they are fine with the state. Means suppose they are fine with the state like yes or no, like true or false, that means like 0 and 1, fine, and that is why they introduce the binary number. Means if computer give the number, computer will represent the number 1, that means the answer is, we can interpret the answer is yes. If the number is 0, we can interpret the answer is false or the answer is incorrect, fine. Now see, first we will see the binary number, what is the base and which are the symbols or digit used in the binary number. See what we mean by the base. So first of all, for example, we are having one number that has the R base, okay. Now what does it mean? What is the meaning of the R? If we are having the R base, that means we can use the symbol up to R minus 1, up to R minus 1, we cannot use the symbol up to R. If the base is R, that means the total number of the symbol equal to R, but the highest number which we have used, that is the R minus 1. For example, if we are using the binary number, means if we are using the base 2, if we talk about the base 2, what will happen? It can use only 2 symbols or 2 digits. These objects are known as the symbols or digit, fine. Here we can write the base 2. That means if we interpret any number in the binary form, we can represent the number in the combination of only 0 1 0 1 0 1 0 1, fine. It is the collection of the zeros and 1. We cannot use any other number in the binary form, fine. Now see, what is the why, if there are the binary numbers and if computer can understand the binary numbers very well, then why there is the need of the octal number? There were some problem with the binary numbers? No, there were no problem with the binary number. But see, if this is the binary number, then now this task also will become complex for the machine also to memorize this lengthy number, fine, to process this lengthy number, also to manage this lengthy number, and that is why we can make, means one can make the group of this binary number, like we can make the group of the 3 3 and represent it as the one number. We also can make the group of the 4 4, fine. If we will make the group of the 3 3, this number will be represented by using the octal number. It is called the octal number. See, again I am repeating, there were no problem in the binary number, but if the sequence of the binary number is very long, then the task will become complex for the machine also, fine. That's why for just the management they are using the octal and hexadecimal number, fine. See, we can, if we make the pair of the 3 numbers, if we make the pair of the 3 numbers in the binary number, then now this number will convert to the octal number, and if we will make the pair of the 4 numbers, so now this number will convert to the hexadecimal number. Now see, might be you have one question, why we make the pair of only 3 and 4, why we have not make the pair of the 2? We can make the pair of the 2, but it will not give too much different, means too much advantage in the representation. Fine, it will not give. Suppose we have one number 0 1 1 0 1 1. Suppose if we will make the pair of the 2, fine, it will not give us too much advantage for the representation. Fine, it will not give us the too much effect on the storage, right? And that's why we are using normally octal and hexadecimal number. Fine, octal is the collection of the 3 binary numbers and hexadecimal is the collection of the 4 binary numbers. Now see, what is the base for the octal number and what are the symbols used in the octal number? This is the binary numbers and these are the symbols for the binary numbers. Now what is the base for the octal number and which are the symbols that can be used in the octal number? So we can use the symbols 0, 1, 2, 3, 4, 5, 6 and 7. Why? Because this is octal number, 8 must not be there, right? Now see, what is in the hexadecimal number? What is the base for the hexadecimal number? It is 16. Now how we will generate the hexadecimal number? We can generate like it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Now what? If we will use 1 0, suppose we will use the 1 0, 1 1, 1 2, 1 3, 1 4 and 1 5. Suppose we will use 1 0, 1 1, 1 2, 1 3, 1 4 and 1 5, then again your machine will not differentiate this 0 1 and this 1 0. Again the machine will not differentiate this 1 1 and this 1. Again the machine will not differentiate between this 1 2 and this 1 2. Fine, and that's why we have to use the different symbol after the 9. We have to use the different symbol after the 9. We can use A for the 10, we can use B for the 11, C for the 12, 13, 14 and 15. We can use D, E, F. Fine. Miss, suppose anyone will ask you the hexadecimal number F, that means your actual number is 15. Suppose anyone will ask you the hexadecimal number D, that means the actual number is 13. Fine. Now let me give one example. We will check which number are correct or which number are incorrect. See, suppose I am writing 0 1 1 base 2. This is the correct binary number? Yes, this is the correct. Why this binary number is correct? Because all the digits or all the symbols are combinations of 0 and 1. Fine. No one digit or no one symbol exceeds 2, means exceeds its limits. Fine. This is the octal number. Yes, this is the octal number. Why? Because all these symbols are less than 8. This is the first thing. Fine. This is the octal number? No, this is the not octal number. Why? Because 9 must not be there, because we are going to represent the octal number. Octal number, that means the 8 base number. Fine. Octal number, that is the 8 base number. So this number is incorrect. Same way, we also can introduce the 4 base number. If we are introducing the 4 base number, then our symbol is 0, 1, 2 and 3 only. Fine. Now see, suppose one will write 1, 2 and 4 and the base is 4. This example is correct? No, this example is also incorrect, because 4 must not be there into the 4 base number. Fine. The last digit should be up to the 3. Fine. Only the digits are allowed or only the symbols are allowed, that is the 0, 1, 2 and 3. Fine. This is the valid hexadecimal number. Yes, this is the valid hexadecimal number. Hexadecimal means the base is 16. Fine. Now see, by using the octal number, by using the hexadecimal number, by using the octal number we can represent the number till 7. What about the 8, 9, 10, 11? We will see this. See, suppose our number is 0, then it has meaning the 0. Fine. Suppose our number is 1, that means it is 1. Suppose our number is 2, it means 2. 3, that means 3. 4, that means 4. 5, that means 5. 6, that means 6. 7, that means 7. Now what about 8? How will represent the 8? Then again we have to use this symbol only from this section. Fine. We cannot use the next symbol because our limit is 8 and we have already used the 8 symbol over here. Fine. Then what we will do? We will represent 8 by combination of 1 and 0. We will represent the 9 by combination of 1 1, 1 2, 1 3, 1 4, 1 5, 1 6, 1 7 and so on. Again if there is the multiple of the 8, that is the 16, that will be replaced by 2 0, 17, that is the 2 1, 18, 19, 20. Again the multiple of the 8 is 24, here we will replace by the 3 0, then 3 1, 3 2 and so on. We will see in depth in the conversations of the number, we will see this topic depth in the into the topic conversion of the number, right. This is all about the decimal, binary, octal and hexadecimal number. I think you people are clear about this basic number system. These are the positional numbers. I am repeating here, there is the importance of the position, means suppose the number will placed at the first position, it has the importance. If the number is placed at the second position, that it has the importance. If the number is placed at the third position, this position will change the number. Fine, this position will change the number, that is why the position is important in the positional number. This is one example. What is the important, which is the base and which is the weight. Here 10 is the base. Why 10 is the base? Because it is the decimal number. Decimal number are also called the 10 base numbers. Fine. Now see, what is this topic? This is the conversion among the bases. First of all, why there is the need to introduce this topic? See, we are having the, suppose we want to add the two numbers, suppose we want to add the two numbers, that is the 20 plus 30. Fine, 20 plus 30. Till now what we learn? We learn decimal number, we learn binary number, we learn octal number and we learn the hexadecimal number. Fine. Now we want to use the calculator of your computer or your laptop or your mobile. Fine. And we, by using the calci, suppose we want to add this two number. Now we are, suppose if we don't have the calculator, we can simply add this. Fine. The answer is 50. But in the case of the machines, again machine cannot understand this 20, machine cannot understand this 30. Why? Because machine will understand the binary number. Fine, because it is easy for the machine to memorize. Okay. Now see, what we will do? We understand the decimal number, machine understand the binary number. Now we have to create one bridge between this number, and that is the importance of this, that is the importance of this conversion. Fine. That means we can convert our decimal number to binary as well binary number to decimal, decimal number to octal as well as octal number to decimal, octal number to hexadecimal, hexadecimal to octal, hexadecimal to binary, binary to hexadecimal, also from octal to binary, binary to octal, and decimal to hexadecimal and hexadecimal to decimal. Fine. Now see, first we will see this conversation one by one. First we will see the first conversation, that is the binary to decimal, right. First I will explain you what is the sequence of computer, means in which sequence computer will work for the numbers. Now see, suppose we are having these two numbers and we want to add this, we want to do addition for these two numbers by using the calculator. Fine, calculator of the mobile, calculator of the laptop or desktop. Now see, first we'll enter the 20, we will write on the calci screen 20, fine, then we will press the plus button, okay, again we will add the 30 and then we press the answer button, fine, we'll see the answer 50. But how the computer will, what the computer did for this? So first when we'll enter the 20, computer will, this number is the decimal, decimal means this is the 10 base number, fine, this number is entered by the human. When we enter the 20, computer or machine will convert this number first into the binary form, okay. Again we use the plus sign, again when we enter the 30, it will convert this number into the next binary form, fine, next binary form. So first time we need to do the conversion from decimal to binary, machine will add two binary numbers, it will give the answer into the binary form, okay, it will give the answer into the binary form. Suppose it will give the answer like this. Can we understand? This is the addition of 20 and 30? No, people cannot understand this, and that's why machine will again convert this number binary from binary to decimal, fine, and that's why we start our first conversion. That's why we start our first conversation, that is how to convert the binary number to the decimal number. Now see, this is the technique how to convert the binary number to the decimal number. First time we multiply each bit by 2 raised to n and then we add the result according to the position. We will see the example. This is the binary number, okay, this is the binary number. How we can recognize this is the binary number? Because it is the combination of the 0 and 1, and second thing here it specify the base is 2, base is 2, that means this is the binary number, right. Now see, we have to convert these number into the decimal number. What we will do first? What is the technique? First we multiply each bit by 2 raised to n, fine. What is n? N will be starting from the 0, 1, 2, 3, dash dash dash, fine. Now see, we will start from the left side, and as the number increase, we will increase the power of the 2, means first from the, we will start from the left side and it is 1 into 2 raised to 0 plus, for the second number we will increase the power by 1, 2 raised to 1, this is 0 power, this is 1 power. For the next number it is 0 into 2 raised to 2, for the next number it is 1 into 2 raised to 3, because our last power is 2, that's why it is 2 raised to 3. For the next number, sorry, for the next 0 number, we increase the power by 4, means power by 1, that means 2 raised to 4, and for the last number 1 into 2 raised to 5, fine, that means 2 raised to 0, any number raised to 0 that always will give you the 1, 1 into 1 that is 1, 2 into 1 that is 2, this is the simplest calculation, the answer is the 43. What is the 43? 43 is the decimal number, fine. This is the procedure how we will convert our binary number to the decimal number. We'll see one more example on how to convert binary number to the decimal number. See, suppose our number is 1 1, this is again the binary number, fine. Now how we will convert this binary number to the decimal? Again we start from the left side, which is the leftmost number, it is 1, fine, which is the leftmost number, it is 1. We will start from the left side, it is 1 into 2 raised to 0, sorry, 1 into 2 raised to 0 plus, again the next symbol is 1, 1 into 2 raised to 1, that means 2 plus 1 into 2 raised to 0, 2 raised to 0 is 1, that means 1. This is the representation of the number 3. Fine. This is the conversion of how to convert the binary number to the decimal number. Next we will convert the octal number to the decimal number. Again I am repeating, octal number is the number which has base 8. The symbol cannot exceed or symbol cannot be higher than 7. Fine. That means we will allow the digit 0, 1, 2, 3, 4, 5, 6 and 7 only in the 8 base number or into the octal number. Fine. Now see, we will see the example. We will see first of all the technique and then we will see the example. Now the technique. Of the conversion of the binary to decimal, octal to decimal is very similar. Fine. Just the change in the this bit. Fine. While we are converting the binary to decimal, that time we multiply the number by 2. Fine. But this time we will multiply the number by 8, means different power of the 8, right, and in last we will add this result. Fine. Now see, this is the example. We have to convert this 127. These first of all we will check this 127 base 8. This is the correct octal number. Yes, this is the correct octal number. Why? Because no one number is higher than the 8. Fine. So this is the correct octal number. Now next we will convert this number into the decimal number. What we will do? Again we will follow the same procedure. We will start from the leftmost, that is 7 into 8 raised to 0 plus 2 into 8 raised to 1 plus 1 into 8 raised to 2 plus 1 into 8 raised to 2. Fine. So 7 into 8 raised to 0, 8 raised to 0 will become 1, so it is 7. 2 into 8 raised to 1, this will become 16. 1 into 8 raised to 2, that will become 64. In last we will add this result, it will give you the answer 87. 87 is the decimal number according to this octal number, right. What is the octal number? Octal number is the 8 base number. Fine. That must not have any digit greater than 8. Fine. First of all, what we have seen today in this lecture, we have started from the number system. First we had started our first block. Fine. That is the number system and Boolean algebra. What is in that block has the 2 units, that is first is the number system and second one is the Boolean algebra. Okay. I explain you what is the importance of the number system. Number system are very useful and that are the base for the computer system, fine, or for base for the any electronic devices. Okay. Next we started from the unary numbers. Unary numbers are also called the non-positional numbers, fine. Majority of the times for the according to the current scenario, unary number cannot do too much calculation and that is why I introduced the decimal numbers, fine. Decimal numbers can use in the complex calculation in day to day life, fine, but there is no problem in the decimal number, but the decimal number cannot be easily understood by the machines, by the electronic devices, and that is why they introduced the binary number system, fine. Binary number system is all the numbers are combination of just the 0 and 1s. No number, no symbol will be greater than, means no number must be greater than the 2, fine. We also cannot include the 2 in the binary number, fine. Then we have seen the octal number. What is the octal number? It is the 8 base number. We have seen the next hexadecimal number. What is the hexadecimal number? It is the 16 base number, right. Now see, from the in the next lecture we will see the rest of the conversion. Till now we have seen only the two conversion, that is the binary to decimal and octal to decimal. In the next session we will see the hexadecimal to decimal, decimal to binary, hexadecimal to binary, octal to binary, octal to decimal, hexadecimal to decimal. Fine.
स्वाध्यायः